Hi everybody, my name is Elias, and today I'll be showing you guys how to perform the dinitrosalicylic glucose assay that's used for determining levels of glucose in a given sample. So the first thing I want to touch on is lab safety. So make sure you're wearing splash-proof goggles, and also please make sure you're wearing gloves. Okay, so the first thing you want to do is set up your heating system. So today I'm going to be using the IsoTemp 215 located in Dr. Fahrenkrug's lab. It has two compartments, one big one and one small one. Today I'm going to be using the small compartment, and make sure it's plugged in before you do anything. So first thing you want to do is fill up that compartment. So go to the ultra pure water dispenser, hit dispense, and then wait until the display reads 18.2 mega ohms. So once it reads 18.2 mega ohms, you can start to fill up your pitcher. Once your pitcher is filled, you can just load it up into that compartment. This compartment holds 5 liters, so you're gonna need to do 5 trips total. So once it's filled up, you can go ahead and turn it on. So just flip the switch, and then it's gonna read the temperature currently in the bath. So while you hold down the set button, you wanna adjust that set point. So right now it's at 89 degrees. I'm holding down the set button with my middle finger, and then I'm pushing the increase button in order to get it up to 90 degrees Celsius. That's where you want to be for this assay. So keep note of that caution statement. If the light turns on, you have to turn the knob. So just pop the lid back on, and you're gonna have to wait like 1 or 2 hours for it to heat up. These are all the reagents you're gonna need for this assay. First up, we have dinitrosalicylic acid, 135 dinitrosalicylic acid to be specific. You're also going to need sodium sulfite, anhydrous dextrose, which is just glucose, sodium hydroxide pellets, and potassium sodium tartarate, aka Rochelle salt. So I'm going to show you how to weigh out your reagents on the analytical balance. So first, turn it on and wait until the display reads 00 grams. Pop in a weigh boat, close the doors, and zero the balance. Once it reads 0, you can go ahead and start weighing out your first reagent. In this case, I'm weighing out the dinitrosalicylic acid. I'm using the spatula, and I'm gonna insert it inside the weigh boat. Today, I'm only going to be making 100 grams of the DNS reagent. So, I'm only going to be making 100 milliliters of the DNS reagent. So that means I need only 1 gram of this dinitrosalicylic acid. And I know I'm a bit obsessive. I like to get it as close to 1 gram as I can possibly manage. That's good enough for me. And so once I'm done weighing out all my reagents, I'm going to take a couple of paper towels, dampen it with DI water, and I'm going to clean the area around the balance and the balance itself, just as a courtesy to whoever uses it next. Clean the display as well. And then once again, inside the balance, that's most important. And you can see how filthy it was, so that cleaning was definitely necessary. And also make sure you turn off the display or turn off the balance once you're done using it. Okay, so now let's talk glassware. I'm going to be using volumetric flasks for this process. On the left, I have a 100 ml volumetric flask. That's where I'm going to be putting the DNS reagent. And you can see that's the laser etched line. That's where I need to fill it up to. That line indicates 100 milliliters. And that is a very, very precise measurement. So I'm going to first load in the dinitro-salicylic acid. In hindsight, I probably should have used a funnel because you can see all the powder flying off onto the bench. So just make sure to use a funnel when you're doing this yourself. Good practice is to just take a little wash bottle filled with DI water and actually wash out the whey boat itself to get all those little specks of reagent into the flask. Ignore all the powder that I spilled on the bench. And then I'm just going to repeat that process for all the other reagents that I need for the DNS reagent, which is just the sodium sulfite, which you can see me loading up there, and then the sodium hydroxide pellets. Okay, so now I got those 3 reagents into the volumetric flask. Now all I need to do is fill it up to that laser etched line with DI water. I find it's easiest to just use a squirt bottle because that way it's really easy to get dispense really tiny drops so that we don't overshoot. So as I approach that laser etched line, I'm going to start to be really careful to make sure that I don't overshoot it. And I'm going to try my best to dispense only tiny drops into this flask. And looks like I did a pretty good job. I did not overshoot it. So now I'm going to prepare the potassium sodium tartarate solution, aka Rochelle salt solution. And you can see we need a whole 20 grams of this stuff for 50 mils of solution. So in this case, I'm 100% going to be using a funnel. And then I'm going to be squirting, I'm going to be dispensing DI water into that funnel just to get that solid to go through. And there it goes. I like to lift it up and gently tap it back down onto the flask to force the solid through. Once again, I want every last bit, so you just saw me dispense some DI water into the weigh boat itself to get the remaining powder out of the weigh boat. And I'm just gently tapping the funnel onto the flask to get that solid to go through. Okay, so all the solid is in the flask. Now I just need to fill it up to that line, and I'm going to be doing the same thing, just being really, really careful to dispense tiny, tiny drops of water until the meniscus just barely touches that laser etched line. And my camera does not want to focus. There we go. Okay, so the DNS and the Rochelle salt solution are ready. They just need to be fully dissolved. So I'm going to do that by popping them in a sonicator for, I don't know, about 15 minutes, however long it takes to dissolve. I would also, in hindsight, use sonication and heat. So this sonicator does not have a heating unit, but the one directly to the left of it does. So just flip the switch on the heating unit and it should dissolve really easily. So now we're going to prepare our glucose standards. So to do that, I have 5 grams of dextrose and hydrous in that weigh boat, and I'm pouring it into a 100 ml flask in order to get 5% glucose solution. Doing the same thing, washing out the actual weigh boat to get every last little bit of glucose into that flask. Then I'm just going to fill it up to that line once again. And you guys already know the drill. I'm approaching that laser etched line, so I'm going to start to be really, really careful and dispense water into that flask drop-wise as best as I can. And you can see me squirting out some water onto the bench right there just to get a flow going. So I brought it up to the line. Now I just need to shake it to dissolve that glucose. And the way I do that is I take a finger, make sure secure the cap, and gently invert it back and forth. I'm not shaking it. Vigorously, because that's a really easy way to get the flask to slip out of my hand and shatter all over the bench. So I have the 3 solutions prepared, but they're not labeled. Please, please, please label all your solutions with lab tape. That way you can keep track of what's in each flask, and everybody else who comes in contact knows exactly what chemical is in there, because it's very, very hard to distinguish one clear liquid from another. So now let's talk pipettes. Today I'm going to be using volumetric pipettes. There's a 10 ml one, a 5 ml one, and 1 ml one, and then a half ml one. These work almost the same way as volumetric flasks. You basically fill it up to a laser etched line, and that is very, very accurate and precise. Alternatively, you could be using a micropipette. I would actually prefer to use a micropipette for this situation, even though they're not the most accurate things in the world. But we ran out of the right tips that I need, so I'm not going to be using those today. So now I'm going to be preparing my glucose standards. So I have 5 volumetric flasks, 25 mils each, and I'm labeling them with the percent glucose concentration that I intend to have in there. And the way I'm going to do that is I'm going to take my 5% glucose stock, and I'm going to be dispensing the appropriate amount of that stock into each of those flasks, and then diluting them up to the line with DI water, and that'll be enough to prepare my standards. So I'm attaching one of those fancy pipette bulbs that have the 3 buttons. I'm going to press the S button to suck up the fluid. And like I said before, these things work almost exactly like volumetric flasks. You want the meniscus to be just barely touching that line towards the top right there. And it's hard to see because my camera doesn't want to focus. But believe me, there is a line there. And the meniscus is barely touching that line. So to dispense the liquid using those special pipette bulbs, you have to press the E button on the side, the eject button, which I'm doing right there. And as you can see, I'm dispensing the liquid into the flask. So to make 3% glucose stock, I need 15 mils of 5% glucose stock in there. So you just saw me dispense 10 mils. Now I need to dispense an additional 5, so that's why I grabbed that 5 millimeter volumetric pipette, and I'm going to be doing the exact same thing that I just did. Sucking up the liquid, filling it up to the line, and then dispensing it. So then, as I mentioned, I'm going to take the DI water and I'm going to dilute up to the laser etched line. And once I do that, I'll have 3% glucose in that volumetric flask. You can see my protocol for how to make the other standards. They all use that 5% glucose stock, just smaller and smaller volumes of it as you go down in glucose concentration. So I'm just gently inverting the flask, once again keeping my finger on the cap to secure it, and just to get it all mixed up nice and evenly. Okay, so once you have all your glucose standards made up, we can start to develop our color. So here we have the DNS reagent, and I'm going to need 3 mils of that reagent in each of those test tubes. And to do that, I'm going to take a 1 mil volumetric pipette, and I'm going to use that to dispense 3 mils of that solution into each test tube. Once again, press the S button to suck up the fluid and press the E button to eject the fluid. Okay, so I got 3 mils of that stuff in each of those test tubes. So that means I'm just about ready to dispense the glucose stock, the glucose standards into each of them. So to start, I'm going to be taking 1 mil of that 5% glucose standard, and I'm going to dispense it into that test tube that's labeled 5%. And then once I've done that, I'm going to clean out that pipette, and then I'm going to do the same thing but with the 3% stock, and I'm going to repeat that for each of the glucose stocks that I have. And the reason I want to do that is because I don't want to cross-contaminate those glucose standards by dipping in a pipette that was just in a different concentration of glucose. So once I've done that, I'm going to take number 3 cork, and I'm going to gently cap each test tube. Then I'll go ahead and vortex it for a couple seconds just to make sure that the glucose and the DNS reagent are evenly mixed together. Okay, so our water bath is at 90 degrees, so that's good. We're going to take heat-safe tongs, and I'm going to gently put it inside of the water bath. And then I'm going to immediately start a timer and pull it out at 1 minute. So 1 minute has elapsed. I'm going to grab the heat-safe tongs. I'm going to pull them out carefully. Don't drop it as I just did. And I'm just going to lay them onto the bench. Then I'm going to take my Rochelle salt solution, and I'm going to be dispensing 1 mil of that into each test tube. So I've got a clean pipette, clean 1 mil pipette, and I'm going to be dispensing 1 mil of the Rochelle salt solution into each test tube. Once I've got that done, I can go ahead and stick those test tubes into my ice bath. So I just got a styrofoam tub full of ice, and I'm just going to stick the test tube rack right in there, and I'm going to try to cover those test tubes with the ice. Although I'm obviously having a hard time doing that. So a much easier way to do it would be to just stick the test tubes directly into the ice, as you see me doing right there. Okay, so those test tubes were sitting in the ice for about 10 minutes, and you can see that this time around I actually didn't develop any color, and to be honest, I have no idea why. There was obviously some issue along the process. My suspicion is that the DNS reagent is contaminated, and or some of the other reagents I used are contaminated one way or another. Because basically the way this assay is supposed to work is that the 3,5-dinitrosalicylic acid is supposed to react with glucose, and then you're supposed to form a different product that has a darker color than that yellow dinitrosalicylic acid. So either the dinitrosalicylic, so clearly that reaction did not occur, and I really don't know why. It's going to require some troubleshooting on my part, but assuming that you do this process just as I did it, it should work for you if your reagents are nice and pure and there's nothing weird going on there. But other than that, that just about covers how to perform this assay. Thank you for your time. I know this is a long video, but it is kind of an involved process, and I want to make sure that I covered every detail so that you guys can be successful when you do this. Thank you very much. Oh, and I forgot to mention that assuming that you've developed proper color on your samples, you should then pop them into a spectrophotometer. And to help you do that, I have another video on this channel where I show you how to use the Carry Bio 100 UV Vis spectrophotometer. And that's a much shorter video and much easier to follow. So give that a look once you're ready to analyze your samples. Thank you very much.